Hello students, welcome to Eshwari Thaniksha channel. In this video, I'll teach you 4 super tricks to solve the numericals on the mole concept. That is from the first chapter, some basic concepts of chemistry. So using those tricks, we are going to solve these numericals from the textbook. That is problem 1.3 and also problem 1.4 we are going to solve using this tricks. So first let us learn the tricks and then solve the numericals. So what is that 4 trick we will see now. So trick number 1. So trick number 1 is you have to check whether the given equation is balanced or not, or else you have to balance the equation. So you have to first balance the equation. So what is trick number 2 then? Trick 2 is write the number of moles of reactant and product we have to write. Trick number 3 is write their stoichiometric coefficient. Write their stoichiometric coefficient. So short form we will be using it as SC. SC is nothing but stoichiometric coefficient. So this is trick number 3. So going for with trick number 4. So trick number 4. So trick number 4 is we have to divide the number of moles. So N is the number of moles. Divide the number of moles divided by stoichiometric coefficient. So this is what is trick number 4. So if you follow these 4 steps, you can solve any numerical in the mole concept. So let us see how to apply these tricks. First, let me take one example and we will use the trick, and then we will solve the numericals from the textbook. So here equation is given. So check whether what is the first trick we are going to follow. Balance the equation. So check whether it is balanced or not. If it is not balanced, you will have to balance the equation. So carbon, here you can see there are 2 carbon atoms, and here also 2 carbon atoms. Hydrogen, if you see 5 plus 1 6, 3 2s are 6, balanced. Oxygen is 3 2s are 6, 6 plus 1 7. And here you can see 2 2s are 4, 4 plus 3 is 7. So the given equation is balanced. So first trick is over. What is second trick? Write the number of moles. So we have to write the number of moles now. So read the question once. What is given? How many moles of oxygen are required for complete combustion of 3 moles of ethyl alcohol? So now, so here we will write number of moles. So for ethyl alcohol, the number of moles is given as 3. So here the number of moles of oxygen you have to find. So let us take it as X. So students, always remember that the number of moles will be given in the question. So question, where you will get these details? So you will get from the question. So you can see here 3 moles. From the question you will get the number of moles. Now what is the third trick we are going to use? Trick number 3 is write their stoichiometric coefficient. So what is that stoichiometric coefficient is? You have to see the number which is present adjacent to the compound or molecule. Here ethyl alcohol you have. So what is the number which is present here? So if there is no number here, it means that 1 you have to write. So here the stoichiometric coefficient is. So I'll write here stoichiometric coefficient, short form SC. For ethyl alcohol it is 1. For oxygen, what is the stoichiometric coefficient? So stoichiometric coefficient is this number, which is 3. So I'll write here 3. So we have followed third step. So what is the fourth trick here? Divide number of moles divided by stoichiometric coefficient. So trick number 4 is, so now we are going to divide number of moles divided by stoichiometric coefficient. Here the number of moles is 3 divided by stoichiometric coefficient 1. So this is equal to number of moles is x divided by stoichiometric coefficient is 3. So here you can see number of moles divided by stoichiometric coefficient for ethyl alcohol. For oxygen, number of moles divided by stoichiometric coefficient 3. So now find x value from this. So you will be getting x is equal to 3 3s are 9 moles. So 9 moles of oxygen. So here in the question what they are asking, how many moles of oxygen are required for complete combustion? So the answer is 9 moles of oxygen is required for complete combustion. Is that clear? So this is how we are going to use these 4 tricks to solve this question. So now using these 4 tricks, let us solve the numericals which is given in the NCERT textbook. So this is the first question we are going to solve. That is problem 1.3. So read the question first. What is given? Calculate the amount of water produced by combustion of 16 grams of methane. So students, such type of question, students feel very scared to attempt this question, because you can see here weight will be given, then molar mass will be given, so some details will be given. So which formula to use and how to solve? So this is very confusing for the students. So this 4 trick you can use to solve these kinds of questions. So let us see how to solve. So what is the first trick we are going to use? Write the balanced chemical equation. So equation will not be given. You have to write the balanced chemical equation. So here it is given combustion. So how to write the equation for combustion? I have already made a video on this. The tricks to write the reaction and also balance the combustion reaction. I have made previously one video. You can go to the playlist and you can check this video. So now first let us write the equation for combustion of methane. So methane formula is CH4. Combustion means you are heating in the presence of oxygen. Product will be carbon dioxide and water. So this is the reaction. So first step is you have to check whether it is balanced or not. If it is not balanced, you will have to balance it. So here how to balance, for that the trick I have already taught. So we are going to use the formula. So here you have to write x and here it is y by 2. So this is x and this is y. So here that trick I have taught in the previous video. So here you will be writing 1 or it is understood. So here you will be writing 1 or it is understood. It is because carbon 1. So here also carbon 1, it is balanced. And here hydrogen is 4. So 4 you have to divide by 2. How much you will get? You will get 2. So you have to write 2 here. So now it becomes balanced. Then you have to balance oxygen. So how to balance oxygen? So again for that there is a formula to balance oxygen. That is x plus y divided by 4. So what is x here? X is 1 plus y is 4 divided by 4. So this will get cancelled and you will get 1 here. So 1 plus 1 will be equal to 2. So therefore you will be getting here 2 oxygen. So is this clear? So for this trick you can go through the previous video with examples I have taught. So this is the first trick now. That is balanced equation we have written. So what is the second trick we are going to use? Second trick is write the number of moles. So where you will have that detail, it will be given in the question. So regarding the number of moles, you see whether it is given in the question or not. So calculate the amount of water produced by combustion of 16 grams of methane. So here moles detail is not given. Instead of that, they have given the mass of methane as 16 grams. So now we have to convert this to the number of moles. For that we have a formula. Number of moles is equal to mass by molar mass. So this is the formula for the conversion. So now find the number of moles. N is nothing but number of moles. So N is equal to mass is given as 16 divided by molar mass of methane. So methane is CH4. So carbon mass will atomic mass is 12 plus hydrogen is 1. There are 4 hydrogen atoms, so you will be writing it as 4. So 12 plus 4 is 16. So molar mass is equal to 16. So 16 by 16 you will be getting it as 1. So the number of moles we are getting it as 1. So now instead of using the weight, we are going to use the number of moles, which is nothing but equal to 1. So now I'll write the number of moles of methane. So I'll write here the number of moles N for methane is 1. And then for what they are asking in the question, calculate the amount of water produced. Water. So for water we should know the number of moles. So we don't know the number of moles because it is not given in the question. So write it as X. In the next, what is the next trick? The next trick is you have to write stoichiometric coefficient. So stoichiometric coefficient here, it is 1. So if there is no number, it means that there is 1. So you will be writing here 1. And for water, what is the stoichiometric coefficient? Here you can see 2. So here you will be writing 2. What is the next step? So the next step is divide number of moles divided by stoichiometric coefficient. So you will write 1 by 1 is equal to X divided by 2. So X value will be equal to 2. Correct? So the number of moles of water. So this is for water. The number of moles of water is 2. But in the question, they have not asked the number of moles. Instead of that, they have asked the amount of water. Amount of water means weight of water or mass of water, you can say. So again use the same formula. That is, the number of moles is equal to mass by molar mass. So this is for water now. So this we are going to use for water. So the number of moles N, we have got number of moles as X. See here, this is the number of moles N. The number of moles we have taken it as X, and X value we have got it as 2. So here we are going to write 2 is equal to mass we have to calculate divided by molar mass of water. So what is the molar mass of water? So molar mass of water will be, so let me write here, where, okay, here let me write H2O. So molar mass of water is 2 hydrogen plus 1 oxygen. So 2 into hydrogen is 1 plus 1 into oxygen is 16. So 16 plus 2 is 18. So molar mass will be equal to 18. So let us write here divided by 18. So now mass is equal to 2 into 18. So 2 into 18, how much you will be getting? You will be getting the mass as 36 grams. Correct? So see in the textbook what they have given. 36 grams of water. So the answer what we are getting? 36 grams of water. So we have used the 4 tricks and we have got the answer. So if you get confused by seeing this, how they have done, so you can use this 4 tricks easily, you can solve. Is that clear, students? Now we will solve one more question, that is 1.4. So again, what is the first trick we have to use? We have to write the equation. So read the question here. How many moles of methane are required to produce 22 grams of carbon dioxide after combustion. So again here methane on combustion. So write the same equation what we have written previously. So you will be writing methane plus 2 times oxygen giving carbon dioxide plus 2 times water. So this is the balanced chemical equation. So what is the second trick we have to write? We have to write the number of moles, that is N. So in the question they have given how many moles of methane are required. Meaning is for methane we have to find the number of moles. So here methane we have to find the number of moles. So let us take it as X. And then in the question it is given to produce 22 grams of carbon dioxide after combustion. So again here for carbon dioxide they have given 22 grams. So here carbon dioxide 22 grams. So again convert this to number of moles first. Only then we can use the second trick. So how to convert? The formula is number of moles is equal to mass divided by molar mass. So number of moles is equal to mass is given as 22 grams divided by number of divided by molar mass. For carbon dioxide, what is the molar mass? Carbon, one carbon atom is present, so it is 12 plus 2 times oxygen is 16. So it will be 12 plus 16 2s are 32. So this will be 2 plus 2 4 44. So 22 divided by 44. So how much you will get 22 divided by 44? So you will be getting 22 ones are 22 twos are. So 1 divided by 2, this is nothing but 0.5 moles of carbon dioxide. So this is calculating the number of moles of carbon dioxide. So instead of using grams here, so now instead of using this grams, I will use the number of moles, which is nothing but 0.5. So here 0.5. So we have used the second trick. Next is third trick. Third trick is finding the stoichiometric coefficient. So stoichiometric coefficient here it is 1. And what is stoichiometric coefficient here? So here also it is 1. Next step is divide the number of moles by stoichiometric coefficient. So x by 1 is equal to 0.5 divided by 1. So x value will be equal to 0.5. That is 0.5 moles of methane. So let us see in the textbook what is given. So you can see here, hence 0.5 moles of carbon dioxide gas would be obtained from 0.5 moles of methane. So how many moles of methane are required? So here they are saying from 0.5 moles of methane or 0.5 grams would be required to produce 22 grams of carbon dioxide. So the answer is 0.5 moles. So here 0.5 moles of methane is required to produce 0.5 moles of carbon dioxide. So is that clear, students? So I hope this trick is very useful to you. Within few seconds you will be able to find the answer. So students, if you like the video, you can share this video with your friends and also subscribe the channel. I'll meet you in the next video, students. All the very best.